I'm also going to talk about GraphQL, more from the aspect of the server side. There will be some overlap with Lee's talk, so I guess you get to decide whether you like information from a dapper guy in a bow tie versus some dude in a Aviato t-shirt. So, I'm an engineer at Facebook. I've been there for about 6.5 years. Lee's actually a little more old school than me. So you just heard me give an overview of the GraphQL system, its history, its syntax, its overall functionality. Today we're going to discuss a few issues mostly related to GraphQL servers. Mainly, what does it mean to build a GraphQL server? It's kind of, I think, hard to conceptualize what actually this server code would be structured as, given the description. And given the release that we have, what can I actually do with it? And then lastly, I think another excellent question that people have is, how would I possibly overlay this on my existing system without being too invasive? And we will go over some approaches about how to do that. And then I'm basically going to do live demoing in GraphQL for about 15 minutes because it's really fun. So what is a GraphQL server? I think it's hard to wrap your hands around sometimes because we didn't release a standalone service. It's like a set of code that you can plug into. So it's useful to go over what it isn't. And Lee went over this point, but it's worth reiterating. GraphQL does not dictate a particular language, nor does it dictate a particular backend. It is a standardized language with a standardized API to access a type system and a way to describe your system that can be built on any language and any storage engine. So what is a GraphQL server? So very, very concretely, it's a server that exposes a single endpoint. That single endpoint takes a string, it parses the string, executes that query, does so within the context of a type system that is defined on the server. That server's type system is available via introspection, GraphQL itself. We're still very proud of ourselves for building that in GraphQL ourselves. Is what I like to call nerd catnip. And then, so how is this all structured? So we kind of break this broadly into 3 major components. On the left is the GraphQL core. So this is the piece of software that we released in the technical preview. In the middle, you have your type definitions. And this is the thing that glues together the GraphQL core to your application code, which you don't need to change in substantial ways, I'll say, in order to use it as a GraphQL system. So here are the 5 components of the GraphQL core. And we divide these in this kind of like broad divisions here, 5 different components. The first is kind of a standard compiler front end. It's a parser and lexer that takes a query string and produces an in-memory AST out of it, abstract syntax tree. And one of the reasons why we extract out this component, other than it's just kind of a well-known thing how to build, there's lots of tools around it, is that the GraphQL core is not just for the server, it's also for client tools. So Graphical, the thing you just saw a video of, uses this component in order to parse, which makes sense. And because it's a JavaScript, well, I'm here, so I have to say it's like the best language of all time, right? But it allows us to embed the same code in web tools and other client tools. So there's a type system. So the core provides an API for defining type definitions. We'll go over an example of that later, or actually right now. So the type definitions, as I said before, are the thing that glues the GraphQL core to your specific application. So this is what this looks like. So this is valid code in the context of the release we just did. And on the left-hand side, this is what defines the GraphQL API. So there's an ID, it's type ID, there's a name, type string, and there's a pic, which is a pic type, which is another user space type defined here. On the right-hand side, you have these resolve functions. These are concretely the things that map the GraphQL domain to your application's domain. Basically, this is what the application code that's executed by a given field. And so the first 2 are just trivial wrappers around properties, right? But getPic could be arbitrary code. It might poke at a configuration, it constructs a CDN URL, et cetera, et cetera. The next major component is introspection. So this, again, is a GraphQL API for querying types. So what this looks like is, for example, you can query for a type named user. It has fields, field has a name, and the names have types. or the fields have types, pardon me. And so if user only had one field, this is what that query would look like. The introspection system, obviously, in order to describe these systems more fully, is actually fairly rich. And interestingly, beyond just the type information that is used at runtime, it also is a place to tuck away metadata. So you have things like documentation and deprecation semantics embedded in this. So for example, here you have a type, again, query user, the fields, they have a description, and you'll see in the GraphQL demo where this string description actually gets surfaced in the UI. And it also gets surfaced, obviously, in the documentation explorer that we use internally that will be built for the external release. And then there's also deprecated fields. So generally the way you achieve backwards compatibility in GraphQL is it's very difficult to remove fields. Right? At Facebook, we have a 2-year, we say we have a 2-year guarantee, meaning like 2-year-old clients will work. In reality, we don't wantonly break old clients. So we effectively treat them as if they're around forever. If you really need to change a field's behavior in a way that's breaking, you generally just add a new field with slightly different behavior, and then you deprecate the old one. Deprecation has specific semantics, so it no longer appears in the query by default. So it disappears from tooling, disappears from type aheads. You can surface it with warnings. It continues to work, right, at runtime, but you can use deprecation as kind of a hint to make tools hide stuff. Then there's validation, which answers this question. Is a query valid within the context of a specific type system? So this is just kind of standard out-of-the-box stuff you get with a strongly typed system. So for instance here, we pass the incorrect type into the order by. It's not a string, it's enum. Okay, you fix that, change it to an enum, okay. Now it's an invalid enum value. You spell it correctly, and you're off to the races, right? And you can do that, since it's in JS, right, you can do this on both client-side tooling and server-side tooling. And we actually anticipate there's going to be lots of server-side implementations that don't even implement validation because they can count on the client tooling to do it for them. Lastly is execution, which is one of my favorite parts. So we often talk about the value delivered to clients in terms of GraphQL, but I actually think it delivers quite a bit of value in terms of structure to servers, meaning it provides a constraint. And in general, at the end of the day, when you write a GraphQL's implementation, you have to deal with asynchrony less than you would before because the centralized execution component does a lot of the complex orchestration for you. You know, the leaf programmers in the system, so to speak, do not have to worry about asynchrony as much because the centralized component takes care of it. So what the executor can do is exploit the parallelism inherent in GraphQL queries. What do I mean by that? So if you look at this, there's 2 sibling fields, right, in this query. There's a pick and there's friends. And because they're siblings, there is inherent parallelism in their execution. Right? You can execute them concurrently, and only if their internal implementations actually conflict with each other do you actually have to block. So if you express this graphically, we'll go through an execution, how this actually ends up manifesting itself in real code. So this is a tree structure that represents the result of that query. So at the root, we have me. And so we need to fetch me. So how would that work? So here's an example of how it could work. Right? We have this resolve function. You end up threading some like global context object, which is kind of the root of your application. In Facebook land, this is called a viewer context. The viewer is kind of the center of it all because our privacy rules are so complex. And we thread a viewer all the way down the stack. Most applications have something like this if they've been good boys and girls and don't rely on global state too much. So you get a logged in user from that thing. And then that passes back into the executor. Right? So the user code gets an object, throws it back to the executor, and now the executor does its magic to thread it through. So if you look at this code, right, I'll go back for a second. So this is the user definition, and we have just 2 fields, like in the example. One is pick, and one is friends. And if you look at these resolve functions, you get past a user. Well, it's the executor that's responsible for taking the user from that global context object, and then threading it through and passing it back to both of these functions. And so now there are questions like, Lee alluded to this in his talk, but where is the parallelism here? And the parallelism is because in JavaScript land, resolve can return a promise. So if you look at this object graph, you get the friends, and then for each one of those friends, you can pass back, have it get the pick, and it returns end promises. And kind of in very concrete terms, it's the executor that has to deal with promise.all. And it's the executor has to deal with error handling and figure out that, oh, promise number 3 is in the rejected state. Anything that abstracts away promises is like psychologically good for me. And so the executor does that. I don't know how you guys feel about that. Likewise, each one of those friends, you can extract the pick out of it. And the same thing happens, right? It can get back a promise. The promise, once it's fulfilled, gets a pick, and then the executor threads that to that resolve method. So it really breaks down your server code into very consumable chunks that end up being relatively simple. And obviously, in order for them to take advantage of the asynchronous of it, they need to return promises, or in other languages, use other asynchronous primitives. But it's really a powerful mechanism. So just to summarize, again, what we released a technical preview, which is the JS implementation of the core. 5 components, the lexer and the parser, the compiler front end, the type system, the API provided to consumers to define their own type systems, introspection, the standardized way to query those user-defined type systems, validation, the way validating that queries are valid within the context of a given type system, and execution, which is a centralized execution engine that manages the process of navigating over the AST, making sure, wiring it up with the type system, and then doing asynchronous orchestration. So now what I'm going to talk about is what I call from REST to GraphQL. So a very common question that we get is, I am very interested in implementing GraphQL. How do I actually do that? I can't just go into the other developers at my company and be like, we should restructure all our servers immediately because I saw this talk. As much as I would love to believe in Lee and I's persuasive abilities to that degree. So what can you do to experiment on this system? So one way you can do this actually is to effectively overlay GraphQL on top of a set of REST services and do, polyfills, kind of like the phrase du jour for doing this type of thing. So we actually have an example where there's this public REST API called Swappy, which is actually a Star Wars API where you can fetch information about the movies and characters and other entities in Star Wars. And it's actually a really well-documented, well-formatted REST API. So if you want to interact with this thing, it's kind of what you would expect from a good REST API. You navigate around the website. You can get stuff with clean URLs. You get results. Those results contain URLs which point to other entities. Implicit in this is that you have to do multiple round trips in order to get all your data. This is a relatively well-documented one. So on the website, they have all the fields, all the documentation and stuff. And here's another example. If you have a list of films that a character's been in, they each have a URL, right? Well, let's look at the graphical version of what that would look like. So to do that, I'm going to go here, and I only have a screen down here, so I'm going to be looking down here. See mouse up there? Oh, there we are. Okay, cool. So this is what Lee showed a video of before. So you can see here, it's all autocomplete-y. And there you go. So, this is querying against your own server. And I don't know about for you, but this tool was kind of life-altering in terms of the flexibility and being able to explore a system. You can just start typing and things magically appear. And it's amazing. So, it catches errors for you. If you do it here, not only does it catch errors, it gives nice error information, right? So unknown thing. If you do an incorrect type, like something, oh, that's actually a correct type. It'll say, actually, it needs type ID, et cetera, et cetera, et cetera. So it's really powerful. Sorry about this. All right. And so on the right-hand side here, can you see this? We have a screen which shows, so I'm on, We're not actually hitting their REST endpoint right now because for fear of Wi-Fi failure, et cetera. So this is essentially a local version of this REST API. We actually just scraped all the data and we're running it locally. But we're doing HTTP requests. We're simulating HTTP requests. So on the left-hand side, you can see what is the equivalent set of REST commands that would be needed in order to fulfill this request. So for example, if we go here, we can get some other information. Imagine though there's a home world, right? And in the REST API, this appears as a URL. But here, we can go here and look, there's two REST requests, right? So you can see how this would kind of work. And so the way this is structured, I'm going to go back here, is that you have a GraphQL structure. You have your own GraphQL server, right? Which has the GraphQL core and the type definitions, right? And the type definitions effectively contain calls to the REST server, which is left unchanged, right? So this would be a very straightforward way if you kind of want to go rogue in your organization and not, change anything that other people deal with. You can just have your own server. Hopefully you can spin up your own server, your own data center. And then these chatty interactions are actually way less expensive than it would be from a mobile client, right? Because it's in a data center. I hope your data center has faster interconnect than public internet. Oh wait, I totally did this out of order. That's okay. All right, I had this clever intro into Star Wars graphical, but there we go. I'll work on the second font next time. So here's another example of something cool we can do. So let me get down here again. So I think this has a starships field. Yeah. Oh, and so the edges and node thing, by the way, is making it so this is relay compliant. So relay conceptualizes the world as edges and nodes. And so in order to force people to go through canonical paths, we actually force people to go through edges and nodes. That's like the core spec. Internally, we have a shortcut called nodes, but that's not important. But I'm just explaining what's going on there. So here's something interesting. All right. Is that better? Can I get a yes? Hey, all right, there we go. You guys are alive. Okay, oh, wait, let's do something fun here. So first you'll notice that there's integrated documentation, right? So this documentation that we turn in the type system is actually surfaced in the UI, which is sweet. And you notice that this thing is actually an array of string. Okay, well that's not that interesting, but it kind of is actually, because if you go back here to the documentation, something actually changed. So on the swappy service that's out in the public, manufacturer actually returns a comma-separated string, right? And we thought, that's a little janky. So, here's like an example. I think this is for the Death Star. So we actually just change this a little bit, right? We apply some type information. We say it's a list of string. And then we put in a little JavaScript, and it's ES6, it's all elegant and stuff. And then we're good to go. And then none of our clients have to worry about parsing this, right? And if you get an Android, an iOS client, a JS client, and the rest of it, you don't have to rewrite this code 3 times. Right? It's way nicer. And then you get this. And then it's strongly typed. So you can co-gen an array of string on the client, and so on and so forth. So again, Lee talked about this. It's also very effective in terms of querying connected data. So let's go back to our favorite demo. Okay, so we're going to swipe at this query. And let's do this all starships. Oh, we have to open it. So there's an all starships query. I think this, okay, there we go. So let's expand this. You guys are just going to have to believe that the data is going to show up. Okay, so first of all, there's 37 total starships in this database. So this code actually manually goes through and does the REST pagination to grab everything. But if you do, for instance, first 7, right, it only grabs the first page, right? Stuff like that. So it handles it. So if we go through here and imagine, let's get the name of the guys. Okay, oops. And the model, it's fun. Costing credits. And then now let's get to the pilots. Okay, cool, we have the pilots. Pilots have names. And see how it's grabbing the starships and then all the people involved? Every request starts out with OMG GraphQL. It's not part of the spec, but it's an addendum. That was supposed to be funny. So you see all the names here. And then you can just further descend, right? Like all those people have homeworlds. And now you can see there's a set of queries. And because all these return promises, right? All the people can be executed in parallel. And then all the plans can be executed in parallel. It's not too difficult to write. So, heading back to the prezo here. So again, as I alluded to before, before, if all you had was that REST API and you're trying to develop a mobile client, this is what your interaction will look like, right? You do a bunch of back and forth on the public internet, but with the REST polyfill, that magic move, you're gonna love that feature. You do over the public internet, you do one request, right? And then it's a server who orchestrates all these different round trips. Oh, do I have a blank slide here? Oh no, I don't. All right, so this is a great strategy for introducing GraphQL to an organization or a system, but it's not still the ideal long-term architecture. You're not going to get the performance you really want. It will make integrating some of the more advanced features that are coming up more difficult, and it's still going to be slower than you want. But it's like, I think if you demo graphical to someone, it's like kind of the system, the value of the system becomes much more self-evident. So let's talk about fragments. So Lee talked about fragments, but fragments are as critical to GraphQL as functions are to a normal programming language. It is the unit of decomposition. And if you build a sufficiently complex system, you will need to decompose this. So they're critical for complex apps. I'm going to run out of time. That's fine. So let's go back to good old graphical. Let's see how this works. So this is actually, at this point, a relatively nested query, right? So let's make a fragment happen. So let's put all the data that's associated with a pilot into a fragment. So you get a fragment, pilot, fragment, on, and then all the types pop up, which is amazing. Let's see here, name, homeworld, name. Okay, whoop. Oh, it's not, see? Look how good this is. First of all, I spelled it wrong. But second of all, it's not used. So what are you doing? Okay, so instead of this, that should be a type ahead. File an issue, please. All right. So here it's the same deal, right? You have pilots, it's the same response, trust me. So now you can make a starship fragment. This is like an extreme typing stance. Been working on my typing yoga. And here we go, pilots. Oh. Pilots, edges, node. Now, will I do it here? I suppose I could have copied and pasted this, but what's the fun in that? And look, the starship fragment squiggles until you do this. And, oh yeah, it worked. All right, let's just prove that it worked by removing something. There, see? All right. So as you can see here, this is kind of how you decompose a query into smaller, more consumable chunks, right? And like Lee said, usually it ends up mirroring the structure of your views, which is super nice. So you might be asking, how do we power this whole system? And that's through the introspection system. So, literally when we do a type ahead, you do a query kind of like this. You have name, person, You get the name of the guy. Okay, so it's a person. Well, let's get the fields on it. Those fields have a name. We need to auto-indent. Type. Okay. Here are all the types of this guys. Let's get a description. So you can see how we built this entire tool on GraphQL itself. Right? You have this query language, and then the world's your oyster in terms of building tooling on this. It's really fun, actually. So let's get back into Keynote here. What am I supposed to talk about next? Who knows? Oh, this is cool. Nope. There we go. Okay. So we also, naturally, this is a React conference, so we have to have a to-do app, right? So I panicked due to the market, and I still haven't shorted the NIBI, but I'm going to do that soon. A little topical here. There we go. So we have graphical working. Get out of my way. Actually, I have a window already for this. Okay. So this is a live app on Parse, right? So you can actually execute this. Let's add to something else. Give talk. Here it's going to appear in the actual Parse tooling. So this is me proving that this is real. Give talks right there. Now if we query this, give talks at the bottom, right? So you can see all this tooling interoperates. And we use the exact same tool against backends as disparate as a REST polyfill and Parse, right? So, what we hope is as this ecosystem builds, you're building backends across a wide variety you're building GraphQL implementations against a wide variety of backends as a community, and then there's this common platform of tooling, which is just unleashes so much value. I kind of analogize it to React Native in a way. React Native is this horizontal platform that's still able to use the native capabilities on each respective platform. GraphQL is kind of in the opposite direction, right? It's this conceptual veneer over all the different heterogeneous backends. And that conceptual veneer presents an API that's super congruent with the way that developers, particularly front-end developers, think about the world. And it provides all this fancy tooling. And that, I'm pretty much out of time, but yeah, thanks for coming. And and we are, I think Dan's about to press the button. We are open sourcing the code of that Swappy wrapper, just so there's an example out in the open.